Impulse forces refer to forces that act over a very short period of time but result in a significant change in momentum of an object. The impulse experienced by an object is defined as the integral of the force with respect to time. Impulse equals integral f dt. In simpler terms, impulse is the product of the average force and the time duration over which it acts. Impulse equals f average delta t. Impulse has the same units as momentum, Newton seconds, NES, and is directly related to the change in momentum delta p of an object. Impulse equals delta p equals m delta v, where m is the mass of the object and delta v is the change in velocity. Key points include impulse momentum theorem. This theorem states that the impulse applied to an object is equal to the change in its momentum. Short duration. Impulse forces act over a very short time, resulting in a large change in velocity or momentum. Real-life examples. In sports, hitting a baseball with a bat, where the bat applies a large force over a short time interval. In automobile collisions, the force during a car crash is large but acts over a brief moment, causing a significant change in the car's momentum. In explosions, the force from an explosion is intense and acts almost instantaneously, imparting a high impulse to nearby objects. Calculating impulse. If you know the force-time graph, the area under the curve represents the impulse. For constant force, it simplifies to impulse equals F delta t. Practical considerations. Safety equipment, such as airbags and padding, increase the time over which the force acts, thereby reducing the peak force experienced by occupants. Engineering applications. Impulse considerations are crucial in designing structures to withstand impacts, such as crash barriers and protective gear.